and at McDonald's this is its point B. So in this case our distance would be A to B, AB. Now what is the displacement in this case? As we know, we require only initial and final position. So this is the initial position A at home and this is the final position B, McDonald's. Okay. So what is the shortest distance between these initial and final positions? It's again A to B, A, B. So in this case, our displacement would be A, B. Okay. So here we have both distances and displacements equal. Okay. Why it is equal? Because the boy followed the shortest route between initial and final position. Okay. So what we conclude from this? The first thing is when we talk of distance, the path which is actually followed by the object matters. Okay. But where you talk of displacement, the path actually follows doesn't matter. It's only determined by initial and final positions. Okay. Now let's look at another example where you will see where distance is not equal to 0, but displacement can be equal to 0. So distance is not equal to 0, right? That means the object is covering some distance, but displacement comes out to be 0. Interesting now. Let's look at the scenario. Let's again consider the same boy and he starts from his home and goes to McDonald's. And what happens when he reached McDonald's? Say for instance he forgot his uh, purse and he comes back to his home. Okay, it means he comes back from McDonald's to his home. So in this case, what is what distance? First he's at home, right? Say at point A. Then he reaches here McDonald's, say B, and then comes back again home. It means it comes back again to A. Now the total distance would be first A to B, then B to A. It means AB plus AB, and that will be 2 times AB because it's covering the same part twice. So this is our distance and it's not equal to 0. But now what will be the displacement? Here, what is the initial point? A. This is the initial position home. And what is the final point? As he comes back from B, it means it's not its final point. Because it turns back, it comes back and reaches here. And this is its final position. It means its initial and final positions are the same. So what is displacement here? When initial and final position same, there is no path, there's no length between, no distance, shortest distance between initial and final position. It means both the positions are same. That means our displacement will be 0, right? So now I hope you are able to understand what is distance and what